Hi everyone. We're going to find information about the Quartic function. It's just exactly like the quadratic function. So the only difference on this one is the table of values is different. Everything else in the graph is a little different. So basically you put in -2. -2 to the fourth goes to 16, maps to 16. And then everything else is the same. So let me show you what that looks like. Basically, what it looks like is the quadratic function, but if you put in some fractional points in here, and we don't even have a 16 on here, so it goes way, I'm going to go ahead and put at 2. I'm going to kind of put it in between here. It's thicker in the origin area, then it shoots up because it's to the fourth, so it's not the best graph, but that's how it is. The domain is all real numbers. The range is just, everything is just like the y is y. The range is y is greater than or equal to 0. What else do we have to answer? Okay, zeros. We have a 0 at 0, 0. Y is positive where x goes to infinity. So y is positive in both quadrant 1 and 2. So basically, y is positive, and it's not negative. So it's positive all the way to negative infinity to infinity. All right, and if we look at the end behavior here, and that's the next two, that's where is the increasing function and decreasing function. So y is increasing. So we're going to say f of x approaches bigger and bigger numbers, which is infinity, as x goes to infinity. And also, on this one, y approaches again infinity, just like we were talking about before. But this is as x goes to larger negative values. So that's that part. It's symmetric about the y-axis. So the symmetry is the y-axis. That means it's an even function. Okay. This function is not one-to-one because when you do the horizontal line test, it hits twice everywhere. So that means we're going to have to restrict the domain when we do the inverse. And we're going to restrict the domain to quadrant 1. That's just standard. So we're going to restrict the domain to x is greater than or equal to 0. All right, so when I do a table of values, we're just going to go from 0, 1, and 2. That's going to go to 0, 1, and 16. And then do the inverse, you just switch the x and the y's. And 16 goes to 2. So, and we're only going to do the, so way down here at 16 it goes to 2. I'm just going to pretend that's 16. So there it is. And basically the inverse is y equals the fourth root of x, where x is greater than or equal to 0. Okay, and if I graph the other part, the original parent function, you can see that it reflects over the y equals x. I'm going a little faster on this one because it's just like the quadratic function. Okay, and we're going to do the general form of the transformation, which would just be the same thing as before. So it's y equals x minus h to the fourth plus k. So the first one, let's just shift this to the right by 2. And if we shift everything to the right by 2, my new center's here. And then 1, 1. And then we go all the way up here. Remember, it's thick through here, and then it shoots up. So that's a shift to the right by 2, horizontal shift. And now let's do the let's go down on this. So we're going to do a vertical shift down by 4. Let's do down by 4. See it better. So from my original, I'm going to go down 4, 2, 3, 4, and then just kind of graph it the same way. 2 is going to go to, say, I can go to 16 on this, I think. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, no. But it's close up to here. So it's just going to kind of shoot up, and it's really thick around the origin here. And I just shifted it down by 2. Okay, that's all of this one. The next one we're going to do is exponents. Thank you, and have a nice day. Bye-bye.